Good day everyone, welcome back to our discussion on the quadratic equation based on the JAMB syllabus, and today we will be discussing quadratic roots. Sum and product of quadratic roots. Now, given that alpha and beta are the roots of a quadratic equation, which is s is equal to alpha or beta, therefore s minus alpha will be equal to 0, or s minus beta will be equal to 0. Rewriting it becomes s minus alpha in bracket s minus beta is equals to 0. Now expanding the left hand side, it becomes s into s minus beta minus alpha into s minus beta is equals to 0. Opening bracket, it becomes s square minus beta s minus alpha s is equals to alpha beta, which is equals to 0. And simplifying further, or factorizing rather, it becomes s square minus beta plus alpha s plus alpha beta is equals to 0. Rearranging it, it becomes s square minus in bracket alpha plus beta s plus alpha beta is equals to 0. Now comparing this with the general form of quadratic equation, that is as square plus bs plus c is equals to 0. Our first step is to divide through by a to make s square to be uniform, and doing so it becomes s square plus b over as plus c over a is equals to 0. Now we are simply going to be comparing both equations. Now comparing, minus in bracket alpha plus beta is equals to b over a, which should make alpha plus beta to be equals to minus b over a. This is the sum of our roots, and alpha beta will be equals to c over a, which is the product of the roots. Now from this derivation, we're able to get our sum of our root to be equals to minus b over a, and the product of our root to be equals to c over a. We have a question from 2000 which states that if the roots of 1 over 2s minus 1 in bracket multiplying s plus 1 in bracket is equals to 0 are alpha and beta, find the value of alpha plus beta, and we're given the option. Now for our solution, first we expand the left hand side of the equation. Doing so, 1 over 2s minus 1 in bracket multiplying s plus 1 in bracket equals to 0 will become s into 1 divided by 2s minus 1, which is in bracket, plus 1 into 1 divided by 2s minus 1 will be equals to 0. Expanding bracket, it becomes s square over 2 minus s plus s over 2 minus 1 is equals to 0. Now multiplying through by 2 to clear fractions, it becomes s square minus 2s plus s minus 2 is equals to 0. Simplifying further, it becomes s square minus s minus 2 is equals to 0. Now we know that alpha plus beta is equals to minus b over a, and from our quadratic equation, b is equals to minus 1 and a is equals to 1. So alpha plus beta will be equals to minus in brackets minus 1 over 1, which is equals to 1, and the correct option is B. We have another question from 1981, and it states that the sum of the root of a quadratic equation is 5 over 2 and the product is 4. The quadratic equation is, and we are given the option. Now from the equation, we are given that alpha plus beta is equals to 5 over 2 and alpha beta is equals to 4. Now recall that our quadratic equation is s square minus alpha plus beta in bracket s plus alpha beta equals to 0. So we'll be substituting for alpha plus beta and alpha beta. Doing so, it becomes s square minus 5 over 2s plus 4 is equals to 0. Next, we are going to multiplying through by 2 to remove the denominator. So multiplying through it becomes 2s squared minus 5s plus 8 is equals to 0. We have another question from 2000 that states that if alpha and beta are the roots of the equation 3s squared plus 5s minus 2 equals to 0, find the value of 1 over alpha plus 1 over beta, and we're given the option. Now for our solution, writing down the equation 3s squared plus 5s minus 2 equals to 0, our first step is to make s unity. Now making the coefficient of s squared unity, you're going to be dividing through by 3, and when we do that, it becomes s squared plus 5 over 3s minus 2 over 3 is equals to 0. Now recall from our identity, alpha plus beta is equals to minus b over a, which will therefore be equals to minus 5 over 3, and alpha beta is equals to c over a, which will be equals to minus 2 over 3 by comparison. Now for our question, 1 over alpha plus 1 over beta will be equals to, simplifying as fraction, it becomes beta plus alpha divided by alpha beta. So substituting for beta plus alpha and alpha beta, which we already know, it becomes 1 over alpha plus 1 over beta will be equals to minus 5 over 3, which is beta plus alpha, divided by, in bracket, minus 2 over 3, which is alpha beta, which therefore will be equals to minus 5 over 3 times, in bracket, minus 3 over 2, which one will multiply will be equals to 5 over 2, and the correct option is D. We have a question from JAMB 2020 that states that the roots of the quadratic equation 2x squared minus 3x plus 2 is equals to 0 are alpha and beta. Find the value of alpha squared plus beta squared. Now for our solution, writing down alpha squared plus beta squared, we know from square identity that alpha squared plus beta squared is equals to alpha plus beta in bracket square minus 2 alpha beta. Let this be our equation 1. And also alpha plus beta is equals to minus b over a, and alpha beta is equals to c over a. Now our quadratic equation 2x squared minus 3x plus 2 equals to 0. A is equals to 2, b is equals to minus 3, and c is equals to 2. So alpha plus beta will be equals to minus, in bracket, minus 3 over 2, which is equals to 3 over 2, and alpha beta will be equals to 2 over 2, which is equals to 1. Alternatively, you can also divide the quadratic equation by 2 to make the s square uniform. Doing so, it becomes s squared minus 3 over 2s plus 1 equals to 0. And recalling our quadratic equation, s squared minus alpha plus beta s plus alpha beta equals to 0, and comparing directly, we can see that alpha plus beta is equals to 3 over 2 and alpha beta is equals to 1. So you can get the value for alpha beta and alpha plus beta both ways. Now substituting for alpha plus beta and alpha beta in equation 1, alpha square plus beta square will be equals to 3 over 2 in bracket square minus 2 into 1, which will be equals to 9 over 4 minus 2. Simplifying, it will be equals to 9 minus 8 divided by 4, which is equals to 1 over 4, and the correct option is B. Here is an exercise for you to try your hands on at home. And for more insight on this topic, you can check out the chapter 4 of our JAMB hidden fact textbook. You can get the hard copy in bookshops, or if you are interested in the soft copy, you can get it at the website on the bottom of the screen. Thank you.